Hello everyone, welcome once again to Beginner to Advanced Excel tutorial, and in this part we are learning about correlation and regression analysis in Excel with examples. So first we will understand what is correlation and regression. Correlation is that it measures the strength and direction of the relationship between two variables. The values in correlation range from -1, that is perfect negative, to +1, that is perfect positive. Then regression helps predict the value of dependent variable y based on the independent variable x, and it gives a mathematical equation for the relationship. These terms will be more clear when we will cover this very simple example. So in this example you can see for a company's performance we have years. So we have 4 years of data. We have ad budget, the amount of budget is spent in advertisement for all these years, and then the revenue generated for these years. Now we will try to calculate correlation. So we will try to calculate the correlation between ad budget and revenue. Similarly, we will try to create performance regression analysis. Okay, so let's begin by copying this data from here. I will share this data file with you. So we will simply save this file as our data set here, and we will call it Corel Rec, so that I will share this file with you. So here we are trying to find out if we increase the ad budget, will the ad revenue also increase, or will the overall revenue also increase, or by spending advertisement budget there is no result on revenue. So whatever the case may be, that is something that we can find out with the help of correlation function. So for this we will simply create a new column and apply this formula. In this formula, which is correl, okay, which is short for correlation, so we will choose two parameters here. In the first parameter you will provide range of first column, and in the second parameter you will provide range of second column. So here B2 to B6 will be our ad budget range, and C2 to C6 will be our revenue range. So let's simply copy this, and we we will call it correlation or COR, whatever you want to call it. And here I will apply the formula. So it has selected the range. When I will hit enter, you will see here the value is 0.98, which is a strong positive value. So result correlation coefficient 1.0 interpretation is a perfect positive correlation that ad budget and revenue in this case move together. So in simple terms, if the value of correlation coefficient is negative, that means the two variables move in opposite direction. A negative correlation coefficient means that when one variable increases, the other variable decreases, which is not the case here. So when we are increasing the ad budget, we are seeing growth in revenue also. So this can be judged from correlation value. If the value is near to 0, that means increase in one variable has very little effect or no effect on the other variable. So you can take different examples and apply this in your case also. Now after learning how to perform correlation analysis, let's perform regression analysis in Excel. So what is regression analysis actually? Regression analysis is a statistical method that is used to examine and model the relationship between one dependent variable and one or more independent variables. So here in our example, ad budget will be our independent variable, and since the revenue depends upon this ad budget, so that will be our dependent variable. It helps to understand how change in the independent variable or how change in the ad revenue influence the dependent variable, influence the how change in the ad spend influence the ad revenue. Okay, and it is widely used for prediction, forecasting, and decision making. There are two main types of regression: simple regression and multiple regression. In simple regression, we examine the relationship between one independent variable and one dependent variable. In multiple regression, you explore relationship involving two or more independent variables. Here you can see we have ad budget and revenue. So here uh, we have one input and one output. The primary output of regression analysis is a mathematical equation written as y is equal to a plus bx plus e, or error term, where y is the dependent variable, which can be sales, revenue, or outcome, and x is the independent variable, example ad spend, time, or input. A is the intercept, the value of y when x is 0. If you put x equal to 0, then whatever is the value of y, that is intercept, or in other words, this is simple equation of a line. Okay, so this line will touch the y-axis somewhere. This intercept is that value. B is coefficient that shows the impact of a unit change in x on y. So B is the coefficient, which is also known as slope of the line. Okay, and E is the error term, that is unexplained variability. Usually the equation of line is y is equal to bx plus a. It is also written like y is equal to mx plus b. There are many ways of writing this line, but this is the primary output of a regression analysis. Its application is in business, that is predict sales based on marketing spend. Something like that we are doing here. Economics is study the effect of GDP on unemployment or employment. Healthcare assess the impact of diet on blood pressure. You know, for example, here you can see in our regression analysis, we are finding out the relationship between WBC and platelets. That if WBC count increases, will platelet count also increase, or vice versa. So here you can see when WBC count in patients is increasing, it is also increasing the platelet count. Okay, so this type of things can be done with regression analysis. And after performing the correlation analysis, let's perform regression analysis in Excel. So first we have to enable the analysis tool pack. So for that you have to go to file, more. In more you will see options. There you will find add-ins. Here you will see analysis tool pack. So you have to use analysis tool pack, and here you can manage Excel add-ins. Let's enable the analysis tool pack and click OK. Okay, so now we have enabled the analysis tool pack, and when you will enable it in your data tab, now you will see data analysis. Okay, so this is very important step. Now to open the regression tool, go to data, data analysis, and select regression. So we will go to our Excel file. Here we will go to data and data analysis. Here you will find various things like ANOVA, single factor, ANOVA, two factor. So let's find regression here. You will find regression here. Click OK. Now it is asking you to input Y range. Y is your output as we suggested, right? Output is revenue. So let's select our Y range like this. And what is your X range? So this is our input range. Okay. So we have written everything here also. So in input range C2 to C6, that is revenue, and input Y range, and input X range B2 to B6, which is ad spend. Check options, you should check labels if you included headers. Okay, so in our case we have not included headers, so we will not check this. If you have included headers, you can check labels. Okay, and here are different things like constant is 0, confidence level, and so on. That is something that you can alter. And select the output range or a new worksheet. So this is important, like where do you want the output. So select the output range, or you can select a new worksheet, and finally click OK to generate the regression output. So what we are going to do, we will just select new worksheet and click OK. Here you will see entire report of your regression analysis summary. Let's read that. So you can see in regression analysis we have multiple R square, adjusted R square, standard error, observation. Okay, we have regression. So we have the, you can see various terms and names here. Okay, important thing that you have to see is in your regression analysis you have intercept, that is coefficient, standard error, t stat. So what is all of this? That is something you have to understand. So now let's try to understand this sample output that we have received, where we have ANOVA, that is analysis of variation, or regression statistics and all. So this is the output of linear regression analysis performed in Excel using the data analysis toolpath. It includes several key components that summarize the regression model, its significance, and the relationship between the independent variable x, that is variable 1, and the dependent variable. Okay, x variable 1 and the dependent variable. So key sections are regression statistics. So multiple R measures the correlation between the observed and the predicted value. Here it's 0.9864, indicating a very strong positive correlation, okay, between the two values, that is multiple R. Then R square indicates how much of the variation in the dependent variable is explained by the independent variable or variables. Here it is 0.973, which can be said 97.3%, meaning most of the variation or variance is explained. Okay, kind of indicates the accuracy. Then we have adjusted R square. Adjust R square for number of predictors. It accounts for potential overfitting in multiple regression. Okay, so which is 0.96. And we have the standard error, which measures the accuracy of predictions. A lower value indicates better fit. So if we have a lower value, it will indicate a better fit, but here we have a higher value. Then ANOVA, also known as analysis of variance. So in ANOVA we have DF, which is degree of freedom, indicates the number of data points minus the number of parameters estimated. Okay. Now we have SS, that is sum of squares. It splits the total variation into regression and residual unexplained variation. Okay, ms is your mean square, that is average variance, that is ss divided by df. These are all statistical measures that are explained to, that are used to explain regression. And f is f statistic, to test if the model is statistically significant. Okay, so that is what you are seeing here. F value is 108. Here you may be seeing it as 3.89 e something because it's a large number. So here you can see, if we will simply increase its size, you will see the actual numbers. Okay, So here for DF, degree of freedom, we have regression, residual and total. Okay. So for every value, you can again revisit the video and see it there. Now, significance F, the p-value of the F test. A value of 0.0019 indicate the model is statistically significant. Typically, it should be less than 0.05. Okay, so this p-value and this r square value is important here, which kind of tells how accurate or inaccurate the model is. Then we have the coefficients table here. In coefficient table, we have coefficient values, standard error, t stat, p value. So intercept the value of the dependent variable when the independent variable is 0. That means where the line will touch the y-axis. X variable 1, the slope or rate of change. That is, for every 1 unit increase in x, the dependent variable increases by 16.212. Okay. So for every 1 unit when we increase x, that is in our case x is add budget. So for every 1 unit change in add budget, there is 16.2162 unit change in the revenue. Then we have standard error, the standard error for each coefficient, and t stat and p value test if the coefficient are statistically significant. We already explained this. And the confidence interval, lower 95%, upper 95%. So here lower 95, upper 95%. So the range in which the true coefficient is expected to fall with 95 confidence. Now final interpretation, the regression equation is y is equal to mx plus c or mx plus b, whatever you want to call. So here you can see y is equal to, let's write it like a standard mx plus b. Okay, so we will write it here. So in some cases it is written like this, some cases b plus mx, whatever is there. So this is the equation line, and based on this line, for any value of x, you can find the value of y. Okay, so this is based on the entire trend, based on the supervised learning from the data, based on the supervised learning from the input and output value. Our Excel has given this line equation to us. For example, if we write, uh, we have different values here. Okay, so not this, we go to sheet 1. So for example, if we spend 5,500, let's say, okay, if we spend 5,500, so 16.22 multiplied by 5,500 plus 13,513.51. So if we will spend this much, so based on the trend analysis, that will be our output. So if we simply see 102725, okay, so that, and here you can see the different values. So it will, you can see it is falling between these two values, because for 5500 ad spend, okay, ad spend, revenue will be this up. This is kind of a prediction that we are doing. Okay, so, and how, with the help of y is equal to mx plus b equation. So this is our correlation and trend analysis, and based on all of this you can find out, and you can apply it on different examples also. So I hope you like the concept, understood the concept. Please keep following the series for more videos.